This is a revision video on the Redox chapter as well as the first page of the metals chapter. Now for oxidation and reduction or redox, the first thing that you need to know is the four definitions for oxidation and reduction. Okay, oxygen, hydrogen, electron, and oxidation state. Now for oxidation state, you need to know how to calculate it. Oxidation state is the same as oxidation number, and it is actually the same as the charge of the substance. So if the substance is in a compound, treat the compound as an ionic compound and then try to split the substance. And the next thing is you need to know the definition for redox reaction, okay, which is a chemical reaction that involves both oxidation and reduction. The second half of the redox chapter, it's about oxidizing agent and reducing agent. And you need to know that for example, for oxidizing agent, two things that happen. First, oxidizing agent will oxidizes another chemical. And the second thing is you need to know that oxidizing agent will itself gets reduced. Okay, oxidizes another substance, itself gets reduced. And in order to test for oxidizing agent, you need to use a reducing agent. Okay, in order to test for whether a chemical is an oxidizing agent or not, you need to use a reducing agent. But not all reducing agent you can use to test for oxidizing agent. So only one of the reducing agent which can be used to test for the presence of an oxidizing agent, and the reducing agent in this case is the Ki, aqueous potassium iodide. And when there is this color change, that means the substance that you are testing is an oxidizing agent. And likewise for reducing agent, in order to test for the presence, in order to test for whether a substance is a reducing agent, you need to use an oxidizing agent. So in this case, it's acidified potassium manganate 7. And when there is a color change, then the substance that you are testing is a reducing agent. And some of the common reducing agents are listed here, those with an asterisk next to it. And likewise for oxidizing agent, these are the common oxidizing agent. Okay, so now now comes to the practice. Basically, I need to point out to you that when explaining why a substance is reduced or oxidized, you can explain it from the point of view of oxygen, hydrogen, oxidation state, or electron. For example, if you are trying to explain from the point of view of oxidation state, you need to find out the oxidation state of the substance, the value of it, and in which substance, and then after that it will turn to the new oxidation number or oxidation state in another substance. So 1, 2, 3, 4. These four are the key points in this question. Okay, likewise, if you are trying to explain it from the point of view of electron, gain or loss of electron, you need to find out, you need to explain the ion in which compound. Then after that, it will become what ion in which compound. So 1, 2, 3, 4. These four are the key points. Okay, now let's look at some simple question. Okay, calculate the oxidation state for nitrogen in the following substances. Okay, my advice is for you to copy down this question, to pause the video and copy down these questions, so that later, after watching the video, you can do it one more time. It's for you to test your understanding. Okay, calculate oxidation state for nitrogen. So you are trying to find the oxidation state for this nitrogen. So how to do it? First thing is the whole thing. What is the oxidation state? The oxidation state of this compound, of this nitrate ion, is actually -1. Okay, So N plus 3 oxygen. Oxygen, what is the oxidation state of oxygen? That means you have to ask yourself, what is the charge of oxide ion? The charge of oxide ion is -2 because oxygen is in group 6. -2. And the oxidation state for nitrogen plus the oxidation state of these 3 oxygen add up together, that would be the oxidation state of this entire nitrate ion, which is -1. Okay, then after that you can solve for N. So N would be -1 plus 6, and that would be plus 5. So the oxidation state for nitrogen in nitrate ion is plus 5. And remember, take note, for oxidation state, the sign is in front, the value is at the back. How about for N2? It is an element, there is no charge here, so the oxidation state is 0. How about for ammonium ion? Same thing, oxidation state for nitrogen plus 4 hydrogen. Oxidation state for hydrogen ion is +1, and that would be +1. If you solve it, N is 1 minus 4, and that would be -3. So the oxidation state for nitrogen in this ammonium ion is -3. How about for NO? N, we don't know, plus oxygen -2 equal to 0. Why is it equal to 0? Because NO, nitrogen monoxide, there is no charge, 0. So solving it, you get N equals to +2. Alright? Now, how about for this question? Sodium and to sodium ion, is it gain or loss of electron? Hence, is it oxidation or reduction? Remember, sodium, this is sodium atom, this is sodium ion. For sodium atom, the charge is neutral, meaning that for this sodium ion, for this sodium atom, the number of proton is the same as the number of electron. For sodium ion, the charge is positive, meaning that proton is more than the number of is 1 more than the number of electron. So in order for sodium atom to become sodium ion, it must lose an electron, and loss of electron by definition is oxidation. Okay, how about this question? SO2 plus X, you get sulfur dioxide plus this X chemical, we don't know what is this, you get sulfur, and sulfate ion plus this Y chemical, again we don't know what is it, you get sulfur. So Y, so from this information given here, Y is an oxidizing or reducing agent. Now let's look at it. What is the oxidation state of sulfur? 0, because there is no charge. How about the oxidation state of sulfur in sulfate ion? This one you have to solve it. So S plus 4 minus 2 equals to -2. So S minus 8 minus 2. S minus 2 plus 6, plus 8, which is plus 6. So the sulfur in sulfate ion, the oxidation state is plus 6. Plus 6 then becomes 0. So it is a reduction. That means sulfate is reduced. Alright? Sulfate ion is reduced. Reduced by who? Reduced by Y. So Y must be a reducing agent. How about X? Same thing. Oxidation state 0 for sulfur here. Oxidation state for sulfur in SO2 is how much? S plus 2 minus 2, 0. So S is plus 4. So plus 4 to 0. Again, SO2 is reduced. That means X is a reducing agent. So X and Y are both reducing agent. Now, which is a stronger, so in this case, which is a stronger reducing agent? Which one is a stronger reducing agent? X or Y? Then we have to look at what is the change in oxidation state. For Y actually make the oxidation state of sulfur to change from 6 to 0. The difference is 6. How about for X? X makes the oxidation state of sulfur to change from 4 to 0. A difference of 4. So a difference of 4, a difference of 6. So which one is stronger? Y is definitely a stronger because it causes a larger drop in the oxidation or a largest decrease in oxidation state. So Y is a stronger reducing agent. Now if the question asks you why, then you can say that because Y causes a larger decrease in the oxidation state of sulfur. Let's look at the next question. X is an oxidizing agent. State the color change when X is added to Ki. Ki is potassium iodide. Now you need to know what is this Ki. Ki is actually a reducing agent, but what is it for? Ki is used to test for Ki. It is used to test for an oxidizing agent. So when Ki is added to oxidizing agent, there will be a color change, colorless to brown. So Ki added to oxidizing agent, so the color change, that means it will change from colorless to brown. Remember, for color change, you must state the original color as well as the final color. How about potassium manganate 7? Now, potassium manganate 7 is used to acidify potassium manganate 7. It is used to test for reducing agent. If the substance that is added to acidified potassium manganate is a reducing agent, there will be a color change. Otherwise, there won't be a color change. So the color will remain as purple. So in this case, color remains purple. Okay. Now the last question, it's about writing chemical equation. Okay, as well as the state symbol. So you need to go and revise your solubility table. QA, Sec 3 work. Which compound is soluble, which compound is insoluble. For example, all nitrates are soluble. Okay, another example, all spar salt is soluble. Okay, so you have to go and memorize, revise Sec 3 work. And for writing chemical equations, you need to be able to identify what are the products. So potassium and steam. Steam is H2O, gas. Potassium, it is a metal. So that would be this part of your metals mind map. Metals and water, you get metal hydroxide and hydrogen. Metal steam, you get metal oxide and hydrogen. Metal acid, you get salt and hydrogen. And for metals here, there are certain metals that will not react with acid, will not react with steam, or will not react with cold water. For example, so remember the cutoff. So for steam and acid, any metals that is below iron, okay, iron would be the last metal that react with steam. Iron would be the last metal that react with acid in this reactivity series. How about for cold water? For cold water, the cutoff is calcium. Calcium is the last metal that reacts with cold water. Okay, so from here, you should be able to predict potassium and steam, K plus H2O, gas, solid. Okay, potassium and steam, what do you get? You get metal oxide and hydrogen. So potassium oxide, which is K2O plus hydrogen. This one is a solid. Then after that you have to balance the chemical equation. Okay, how about calcium and water? So same thing, calcium and water. Water is liquid, calcium is solid. Calcium and water, which is metal and water, you get metal hydroxide and hydrogen. This one. And then plus hydrogen. And then this one is AQ as well. Okay, so the other two, iron and acid, there will be a reaction. But for the last one, copper and nitric acid, this one there won't be any reaction, because the last metal in the reactivity series that react with acid is iron. Copper is below iron in the reactivity series, so this one no reaction. This one there will be reaction. Okay, now let's look at the 10-year series. Okay, 10-year series, Redox, year 2008. Substance X produces iodine from aqueous potassium iodide. So aqueous potassium iodide is Ki, iodine, group 7, is diatomic, I2, and changes acidified aqueous potassium manganate 7 from purple to colorless. So again, potassium manganate 7, it is used to test for a reducing agent. If there is a color change, means that the substance is a reducing agent. So by virtue of this information, we know that X is a reducing agent. Okay, so X is a reducing agent. So the answer can either be B or C. So we have to find out whether X is also a oxidizing agent or not. X produces this from potassium iodide. So Ki change to I2. Now looks at the oxidation state. Oxidation state for I2, 0. Oxidation state for Ki, for this, how about for iodine in Ki? So we have to split it. K is K plus, I is I minus. So the oxidation state is -1. From -1 to 0 is an increase in oxidation state. Okay, so X actually oxidizes Ki to I2. So X is an oxidizing agent. So therefore the answer is C. Okay, it is both an oxidizing agent and a reducing agent. Now how about for this? The reaction between iron 3 ions and iodide ions is represented by this equation. Which statement is correct? Fe3 plus ions are oxidized. Fe3 plus become Fe3 plus, Fe2 plus. So this one is a Fe3 plus to become Fe2 plus is a reduction. So it is reduced by gain of electron, because Fe2 3 plus to 2 plus is gain of electron. So the answer is B. Now how about 2012? This question. Substance X turns a solution of acidified potassium manganate 7 from purple to colorless. Again, from purple to colorless, that means your X must be a reducing agent. What must solution X contain? It must contain a reducing agent. Alright, that's the end of the revision. Thank you.